Tonight you're going to be learning about points of inflection and concavity. So I'm breaking these up, although we're going to be practicing this skill twice. I'll try to go as quickly as I can so these videos will not be long. But for the first one, is point of inflection. So a point of inflection is where the original function changes concavity. And what I mean by that is if I have a graph and I am changing from, that looks like I'm kind of an upside down parabola, and I'm going to change to a positive parabola. A point of inflection is where that change occurs. So right there would be a point of inflection. Okay. And so what that happens on a point of inflection, when you take your second derivative is going to be changing signs, meaning if I was going to use a sign chart, I'm going to be going from positive to negative or negative to positive. In this case, inflection points, it doesn't really matter which one's positive, which one's negative, the order, like it does with local maximums or minimums. And all that matters that it changes signs. The other part that we're going to be talking about is concavity, and so what that means is which way is it curved. And so if it is curved down, that means it's going to be concave down. And that means your f prime or f double prime is negative. If it is concave up, let me change colors here. Try that color. That means your second derivative, f double prime, is positive. Okay. And so you can see I have a list of how do you find this. So you want to make sure you want to find, similar to finding extrema, you want to find where your second derivative, in this case not your first derivative, is 0, or undefined. Again, undefined means a lot of times what you're going to be using is where your denominator is going to be equal to 0. Alright, first example, write the equation of the line tangent to the curve y equals x to the third plus 3x squared plus 2 at its point of inflection. So we need several things here because we're using the tangent line. We're going to need to find what is our point of inflection. That's going to be our x-coordinate. From there, once we have our x-coordinate, we can find our y-coordinate. And then using our first derivative, we can find our slope. Okay, so let's go ahead and get started. So if I take the derivative y prime, actually I'm going to use up as much space as I can, y prime is going to be equal to 3x squared plus 6x. Well, that means my second derivative is going to be 6x plus 6. And just like finding extrema or critical points, we're going to set our derivative equal to, or in this case our second derivative equal to 0. So 0 is equal to 6x plus 6. If I subtract 6 from both sides, I'm going to get x is equal to -1. So at least that gives me my starting point. And so now I know, for my point of inflection, I know what my x-coordinate is for my y minus y1 over x minus x1 times your slope. Okay, so right now we got our x1. To find our y-coordinate, all you're going to do is you're going to plug in. So we're going to plug into the original function. So y of -1, again going back into the original function, is going to be -1 to the third plus 3 times -1 squared plus 2. Well, that's going to give me -1 plus 3 plus 2, and that is 4. So there's my y-coordinate. And so now let's find our slope. And so to find our slope, we have to go back to our derivative, our first derivative, and plug in our point of inflection. So y prime of -1 is going to be equal to 3 times -1 squared plus 6 times -1. And so that's going to give me 3 minus 6, which is -3. And so now I can use all that information to create my tangent line. So I have y minus 4. Again, that's my y coordinate, is equal to my slope times x minus my x coordinate, which was my point of inflection. There we go. Alright, number 2, the graph of y equals 3x to the 4th minus 16x to the 3rd plus 24x squared plus 48 is concave down for 1 intervals. Again, when we talk about concave down, it means it's where it's going to be, almost looks like a negative parabola. Granted, that's not saying that it's not going to keep on continuing. I'm just saying where it looks like it's upside down. And so let's go and take our first derivative. So y prime is going to be equal to 12x to the 3rd minus 48x squared plus 48x. That means y double prime, or the second derivative of y, is going to be 36x squared minus 96x plus 48. And again, just like critical values, we're going to be setting our second, in this case, second derivative equal to 0. And since I have such large coefficients, I'm going to factor out my greatest common factor, which is going to be 12. And so from here, I can go ahead and factor. So I'm going to split up my coefficient for my 3's. That means these two, both of those have to be one has to be 3x and one has to be x. And so now I just want to find, I'm just going to use guess and check. What if I break up positive 4, what gives me a negative? If I multiply my factors together and then add them, what gives me negative 8? So I know these two need to be negative. I'm going to try 2 and 2. So 3 times 2, or 3 times -2 is -6, plus -2 is -8. Yep, there it is. So 0 is equal to 3x minus 2. I'm going to split up my factors. 0 is equal to x minus 2. In this case, x has to be 2. In this case, x has to be 2/3. Alright, from there we can use our sign chart. And so I'm going to plug in, here's on my number line, here's 2/3. Over here it's going to be 2. And again, we're going to be listing our factors. And so my factors in this case are going to be, I have one factor of 12. I have another factor of 3x minus 2. And finally, a factor of x minus 2. So I'm going to list my factors over here next to my number line. And once again, I'm going to be plugging in values into my factors. Alright, so if I plug in, well, there's no x coordinate or any x for 12, so I can just take the sign for 12. So 12 is always positive. Alright, now I'm going to work with 3x minus 2. So if I plug in a value less than 2/3, I'm going to say 0. So if I plug in 0 in for that x, I'm going to get 3 times 0 minus 2 is going to give me a negative number, not a negative 2. Alright, so now I'm going to pick a number between 2/3 and 2. I'll go ahead and pick 1. So 3 times 1 minus 2 gives me a positive number. And then I'm just going to pick a value greater than 2. Let's say 3. 3 times 3 minus 2 also gives me a positive number. So now I'm going to come down to my last factor. If I plug in a value less than 2/3, say 0, 0 minus 2 gives me a negative 2. That's a negative number. If I pick a number between 2/3 and 2 on my number line, say 1, 1 minus 2 also gives me a negative number. And then finally, if I pick a number greater than 2, let's say 3, 3 minus 2 is a positive number. And so now I can just multiply through. So a positive times a negative gives me a positive. A positive times a negative gives me a negative. A positive times a positive gives me a positive. So that means my graph, if it's positive, that means it's concave up. If it's negative, that means it's concave down. If it's positive, it's concave up. And so they want to know for what interval or intervals is my function concave down. Well, that's going to be concave down from 2/3 to 2.